Okay, so what you've learned so far is the difference between pools that contain acidity within soils. And so if your soils are acidic because of the 7 factors at least that we described earlier in this unit, how do you improve pH so your plants do better? They grow better. And this is basically a function of neutralizing soil acidity to raise the soil pH. So there's very common approaches to doing this. And the common approach is this, that you neutralize soil acidity via the incorporation of something called a liming agent. A good liming agent needs to do two things. It needs to neutralize the active acidity, so the acidity in the soil solution. And number two, it needs to exchange basic cations for acidic cations on cation exchange sites to neutralize the buffer acidity, or in this case on this slide, it says potential, but buffer acidity. There's a number of different liming sources that you can purchase that are out in the market today. They all cost different amounts. We'll talk about those in this unit as well. So neutralizing soil acidity, it's that simple. It's a two-step approach. It looks simple on paper. We're going to walk you through how to actually calculate this in this unit. So the goals of liming, why would you want to lime in the first place? So some basic goals. You want to increase the pH of the soil. You want to increase the pH of the soil because plants like a target range, right? So if your soil is acidic below 5.5, you're likely going to have issues with aluminum toxicity. Below 5, you're going to have issues with um, micronutrient toxicities, etc. We talked about this already in this unit. So to increase the soil pH, what do we target? There's been historical targets. If you go back to when I took this class, the target was between 6, 8, and 7 in terms of pH. Our current targets roughly range from 6 to 6.8. And in Ohio, we target 6 to 6.5 if the subsoil pH is greater than 6, and we target 6.5 to 6.8 if the subsoil pH is less than 6. Okay, and we do this hopefully to help neutralize some acidity in the subsoil at that higher target range. These numbers come from this fact sheet that you see here in the slide set. Okay, and I'm going to draw upon this several times in this unit. If you're dealing, and I should mention that these two targets, 0.1 and 0.2, are targets for soils that are dominated by mineral phases. They are not organic soil. So if you have an organic soil, like a histosol, which is greater than 20% organic matter in the soil profile, at least the top plow layer, those organic soils we typically target between 5 and 5.5, and in Ohio we roughly target 5.3. So we, as a goal, try to increase pH and hit a target pH. The second goal of liming is to reduce toxicity, specifically with aluminum. Okay, and we learned about this earlier, that aluminum toxicity occurs at pH values less than 5.5. And we also, number 3, reduce hydrogen toxicity. This occurs in soils that have a pH of less than 4.5, but it can occur. And so if we raise the pH, we reduce the amount of available free hydrogen ions in the soil. And overall, the goal is to really improve nutrient availability and improve plant or crop growth. And it's all based on this figure down in the bottom right-hand corner that we talked about at the beginning of this unit, right? There's a sweet spot somewhere in here that's probably around 6 to 6.5, where most of these elements are highly available. And thus, if you're at 5.5 or lower, you and your crops actually are missing out on available nitrogen, phosphorus, potassium, sulfur, calcium, and magnesium, right? These are all macronutrients needed in large quantities. So we line to raise the pH for 4 different reasons and ultimately to improve nutrient availability. So how does this work? This is how this works. We neutralize free hydrogen ions, right? We do this via adding a liming agent. So the liming agent that you see in this reaction is calcium carbonate, right? And this is relatively straightforward. We add a material that has a base cation, oftentimes calcium, sometimes magnesium, or sometimes calcium and magnesium in combination. This base cation can exchange hydrogen ions on clay surfaces if you add calcium carbonate in large enough quantity. The calcium replaces the hydrogen, which is what you see on the right of the reaction, and then the free hydrogen reacts with the carbonate from calcium carbonate to form carbon dioxide and water, right? So this occurs. What also occurs, right? Well, what also occurs, this is the same scenario, just showing you the clay particle and calcium carbonate replacing the two free hydrogen, well, they're not free yet, but two hydrogen ions on the clay particle and kicking those off and replacing them with calcium, which has a +2 charge, and the hydrogen ions both have +1, and those hydrogen ions react with the carbonate to form water and CO2. So this is one of the reactions that occurs when you lime a soil. You want to remove the free hydrogen ions from the buffer pool. Those are the hydrogen ions stuck on the clays. The second reaction that we need to follow is to neutralize aluminum and potentially iron on the exchange sites. And this process is a little more complicated than what I just showed you for hydrogen. This is a 3-step process, right? It starts off with step 1 by exchanging aluminum off of the cation exchange sites. We still use calcium carbonate, and that calcium kicks aluminum off the exchange sites. On the product side of this reaction, the calcium has removed aluminum. The aluminum now goes into the soil solution where it undergoes hydrolysis, or it undergoes hydrolysis. We'll leave it at that. Here's CO3, okay? Carbonate. We'll come back to this one in a minute. Step number 2, or letter B, aluminum, and if you were to kick iron off the exchange sites, undergoes hydrolysis, the splitting of water. And when this occurs, aluminum reacts with water, and in this case, well, it typically forms 3 free hydrogen ions, but there's 2 aluminum, so in this case, it's forming 6. And it forms a mineral called gibbsite, which precipitates out. It's a solid phase. Then what happened? We just generated more acidity. Oops. Well, it just so happens that these 6 hydrogen ions can react with the carbonate from step letter A up here, and the carbonate reacts with the free hydrogen ions to neutralize the acidity. So this is all taken together in one giant step or 3 sub-steps. This is what happens when we lime a soil. We remove free hydrogen ions, like you saw on the previous slide, and we remove free aluminum ions from the exchange sites, and we reduce the subsequent acidity that's generated in the soil solution.